This is issue number 32 for the Kaiju Engine, where we're going to set up a very basic OpenGL implementation, mainly in Win32, but we'll try to get it also in X11. So we'll see what we can do there. Now this is a very, very basic implementation. I just want to clear the screen using OpenGL. I don't want to draw anything or anything like that. Just kind of get the framework in. I was using this OpenGL Win32 sample code before for playing around, but it uses the GL begin, end, and flush, and we're going to be using more of GLES2, OpenGL 3.3, that sort of range, because it's going to play a lot nicer with our Vulkan implementation, so that pretty much everything can be shared. Just how we go about rendering is going to be split, but this makes it a lot easier when those are in parity. So I'm going to probably use this. I found this pull request on IMGUI from 5 years ago. And this one, I believe, is using 3.3, here for the major minor version. So we're going to be working with this guy here and seeing what we can pull out of this. And this is nice because it's part of their examples, so it's all self-contained in here. And we'll be working off of this and implementing it into our setup for our Win32 code. So in the previous issue, we separated out all of our functions into the WinProc. So we have, I just opened up that tab to get rid of all those red squigglies. So yeah, we separated it out to the WinProc, and that's going to make it easier. Now inside of the paint, we can do our fancy OpenGL code here, and we're going to do the initialization code down below. So down here, when we create the window, as part of the window itself, we're going to have to, I don't recall if it's probably after we create the window here, to do setup OpenGL context. And that's essentially what we're going to be pulling out of that sample code, which I'll take a look at now, and I'll be right back. Okay, so we'll just create a function, setup OpenGL context, and that'll probably return a context or something. I'm not sure yet, but let's pass in the HWND. We're likely going to need that to pull out the HDC device context, I think it is. So I'll create this function up here. And then we will copy, no, not that, HWND. Now the way they have their pixel descriptor set up is like this. I don't really like this, not very readable. So we're just gonna set it up a different way, because C is a little more flexible these days, where we can, rather than mem setting to 0, because they're setting all these zeros, you can just put a 0 here, and that will be equivalent to that mem set 0. And then we can come in and we can set up each one of these fields. And so I'm going to have to look up the order of these fields, or what they are. Okay, so we have the pfd.size, which is going to be the size of, and we can just put pfd here. That's 1. We're going to have pfd.version, which is going to be equal to 1. That's what we have here. Next, we're going to have pfd.dwFlags, which is what we're looking at here. Then we're going to have the pfd.iPixelType, which is what we're looking at here. And then we're going to have the pfd.cColorBits is equal to 32, which is what we have here. We got a bunch of zeros, and then we come down here to the 24, which I believe is the depth. So we do pfd.depthBits is equal to 24, and pfd.colorbits is equal to 8. I think that's the order. We can always go to this guy to find out. Yes, it's probably easier to go from back to front. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A layer type is plain. 6, 7. 6, 7. Oh, that's a stencil bit. So it's depth and stencil. Setting the stencil to 8. Oh, I already set the color bits. Duh. Stencil. Stencil bits. It's going to be 8. And so the plane was 1, 2, layer type. PFD.layer type is equal to plane. And that will set up that structure in a more sane way than that other way. We are going to need the I think it's hardware description context. I don't know what HDC is. What is HDC? Is this even going to take me there? It's not going to tell me. Okay. Well, anyways, worth the effort, I guess. So now we're going to choose the pixel format. So int pixel format figured that out for us. If the format index is equal to 0, then we're going to we're not going to write fatal because we don't have the ESM in here, but we can return a const char star, and then we can just return this built-in string here. Did I spell this right? Format index pixel format is going to be that. So we're going to return that error if we have an error. Next, we're going to say if not set pixel format, then we're going to say failed to set the pixel format. HGLRC legacy context is equal to WGL create context. I'm just going to call this CTX actually, context. Keep it simple. Now we want to say if the context is null, return failed to create the OpenGL context. Then we can do if not WGL make current context, failed to make the context current. And then we want to say int flags is equal to WGL context forward compatible bit ARB. And then const int context or CTX ATTR, the context attributes. We're going to say, this is where we set the versions. Let's see if it picked this up. I mean, it's AI. It probably picked it up from GitHub. Set the ARB3, WGL minor ARB3, and then, oops, didn't mean to click that. The flags ARB, flags, WGL profile mask ARB, WGL context profile bit ARB, and then 0. Yeah, so those are the same. Now we're getting some red stuff here because we actually need to include our GL stuff in here. Include GL, and we will also need to include the we'll need to link the libraries for Windows, and there's 2 libraries we'll need to link. I think it's DGI32 and OpenGL32 are the 2 libraries we'll need to link. So now let's see. Are these part of the X library, GLX or whatever? Let's just carry on and worry about that later. Next, we need another crazy pfnwgl create context attribute attrib attribs attrib is it attribs ARB proc. I don't know how they're expecting people to remember all that stuff. I'll just call it CTX ATTR ARB, I guess. And we don't need to set it to null. There's a function we can call. Let's see, WGL get proc address for WGL create. Oh yeah, actually, since it's the string assignment, we're just gonna go ahead and name it the same exact thing. So if this is null, meaning it didn't find the function, we're going to say that we failed to find the function. So now new context. This is the render context. Rendering context. To be able to create attribute. So we're calling that function, passing in HTC 0 and the context attribute. Of course, if that failed to get the context, then we're going to say we failed to get the render context. And next in the example, we have destroy dummy contexts. So not sure what this is for yet. We'll see if we need it though. So bool result is equal to WGL make current render context. Otherwise, we're going to say res is equal to WGL delete context, and this is going to be the legacy context, what they mentioned there. So maybe I should name that legacy context just for clarity. Legacy CTX. I don't think Visual Studio Code is going to want to work with me on find and replace with symbol replacements. So we're just going to copy paste replace. Failed to delete the legacy context, and then we're going to make the rendering context current. So if not WGL make current rendering context, failed to make the rendering context current. And then we're going to set up the vsync. I want to label that just so I know what the heck is going on here. Swap interval extension. If we didn't find it, WL swap interval extension 1. So we probably want to, this is the skip count. So we probably want to set that to the skip count. I'm going to just create a const here real quick to constant frame vsync skip count equal to 1. That way we're not just shoving 1 in there and not knowing exactly what it means. And then we are going to return null, as in there's no error. Cool. Some of these guys, I wonder if they're in a different header. We'll find out. So let's try to call this and see what our errors are. Of course, we need to link. Oh, we are calling this. And we're doing nothing with it. So first, let's say const char star the error. If error is not equal to null, fatal the error. Okay. Now instead of VS Code launch, we are now going to have some environment variables because we are going to be doing the linking here. So LD flags, we're going to L a GDI, I think it is, 32, and L open GL 32. So let's just copy that and paste it here. And those are going to need to be linked in our build scripts as well if we choose to use OpenGL. So there's going to be a little bit of back and forth on this build script, I think. So we'll just add it as part of this guy here. Oh, actually for Linux, I don't know what it's going to be yet. For Windows BAT, we need to do set CGO flags equal to this. Okay. We don't need to do it for the JavaScript one. So just this bat for now. And we can also copy that over into our project template, build bat. Okay. So let's try to run this and see what happens, see where we made a mistake. By we, I mean I. So I got some errors here. It's likely due to me, WGL stuff, probably missing an include. So let's see. Do I need to get the GLU? I think that's the utility header. Let me build that and see what happens. Nope, WGL context for. Let me just see what library this is in. Oh, I see. This is actually part of glue. I was seeing how far I could get without getting into glue or glad or any of those wrangling, OpenGL wrangling. So you can pretty much get all the way in on the old like 2.1 or whatever, but it gets much more complicated as you carry on with the higher versions of OpenGL. So it might be easier just to go grab that header and pull it in and then continue messing with this. Okay, I actually had a version of Glad from my C engine. So the C engine used Vulkan and OpenGL 3 as well. Yeah, 3.3 and GLES. So we will work with that one, or we'll see if that one will work with us, that is. So let's just try include glad.h in here. That seemed to make these things happy, so let's see if that makes the compile happy. Okay, compile is not happy. It's happier than it was, but still not happy. OpenGL already included. Remove this include. Okay, so it's probably a complaint about that guy being included. Okay. No such file or directory. The KHR platform. Oh, I forgot to copy that file over. And I'm actually going to change that KHR platform. I'm going to change that to just be in the same directory here. Okay, I've copied that one in now as well. All right. So now we're back to complaining about these guys. Are these guys even in Glad? Nope. Let's try context forward. Nope. GL context flag forward compatible bit seems like a valid replacement. Let's find out. Oops, I guess it doesn't like that. 131. So if I put this as the flag, and then let's say context major. Oh, my glad went away. Major. GL major version. GL minor version. Context flags. Context flags. Context profile mask. Let's look for profile mask. There's context profile mask. Let's look for core profile. Oops. Core profile bit. Okay. Looks like it's just replacing the WGL in here. So now we've got this crazy thing. Let's see if we have anything similar. Do we have anything that ends in proc? Yes, we do. So the one we're looking for is GL create context. Let's look for create context proc. Anything with context proc? No. Okay, so I was looking for a const char name in here with an proc, so maybe this glad load proc. No idea. Glad load proc. It's type definition. So perhaps that will make it happy. This is a swap interval proc. But the problem is we expect it to have certain arguments. So maybe there is one that matches. I think in GL it's like GL char. Yeah. Vulkan pra. No. Okay, so we can also search for The first argument is an HDC, which is of type HDC, so maybe we can go into GLAD and look for, oh, HDC doesn't exist. So maybe this is an extension I don't have. Okay, I just realized this was a WGL. I didn't even look at the string. So I grabbed some WGL files here from GLAD, the GLAD generator. And I don't think we need the GLAD anymore, so we'll see. We'll call it GLAD underscore WGL and see if that makes things happy, because the GLAD WGL does have this. I put two B's in there, what we're looking for. So let's see if that gets us further. We got glad slash glad is being included from here, I think. So we're just going to change this to single quotes glad.h. And let's make sure these are also properly, yeah, single quoted here. KHR platform, because I overwrote this file. That's why we need to double check. Yeah, no includes in that one. So let's see, KHR platform is still good here. So let's try that one. Hey, it compiled. Even though we got a failed to create rendering context, which could be my fault or it could be the fault of me using the incorrect GLAD file. So let's see. Rendering context. Failed to create the rendering context. WGL, create context attributes. So it did find this function. And let's see, context attribute. Let's change these back to what they were. So I'm going to undo all of these. Yeah. Change this back to GLAD WGL. Come down here and paste it here. So now these are all the correct flags. I don't know if they're identical between WGL and GLAD, but I would imagine they should be. Anyways, now we have our window. The context was created. We didn't panic for anything. So we've got all of those guys set up, and now we need to go back and finish clearing out the screen. I think I'll need to initialize GLAD. I'm using it, obviously, since I'm using GLAD init. It's a little different than the example I'm going off of in that pull request. Okay, might be okay. Let's see if there's an init function in here. Affinity. Nope. Okay. So cool. We'll see how it goes, I guess. And this is red because it wants me to cast it because it thinks it's C++. Maybe if I go to C, it'll be happier. Nope. But it doesn't matter. It casts fine in C. You don't need to typecast. It's obvious what I'm casting this void pointer to. Okay, let's just set up the code for OpenGL and we'll figure out the initialization stuff after. Okay, so we have a paint, but before the paint, we're actually going to have a size. So let me just put that in here. Case WM size. And this is where we're going to set our viewport. So we'll say GL viewport, and we'll say 0, 0, and then L_, that's correct. And then we'll post a paint message. So post message HWND paint 0, 0. So that will set up our viewport. Anytime it changes, it just sets it to the size. We may do this somewhere else in the engine, but good enough for now. And here we don't need to do a fill rect anymore. We're going to be clearing the screen. So we're going to call out our GL clear color. We're going to set this to 0, or let me see. I don't know what the colors are for this, but let's go traditional. Clear with cornflower blue. See what the AI says cornflower blue is. Okay, so we set the clear color, and then we're going to say clear the color bit. We're going to have other bits that we're going to have to clear there. Then we're going to swap the buffers, and then end paint. I don't know if end paint comes after swap buffers. I think it does. We'll find out. So let's see where we're at here, if we get any exceptions because stuff isn't loaded or anything like that. Looks like linker errors. Yeah, LD executable, undefined, glad clear. Okay, so let's check out our, this is a build error, but I think I looked up that initialization because we're going to need to do that. Set up OpenGL context. I think before we start, we can say glad load GL. That's going to be our function here. We don't have the proc address on these guys. These are pretty much for, we use those with the like GLFW or something like that. So I think we just do glad load GL, and this returns an int to tell us whether it's good or not. So if this is equal to 0, failed to load glad GL, we'll have that. So now we're going to check out this undefined reference, and it could just be because we need to set a define for glad. It's been a little while. I've been in Vulkan for quite a long time now. So we may need to set up a define. Oh, I forgot to copy over my glad.c file. Okay, glad.c in place. Let's try to run this. See what happens. Need to change that again. Glad C. Glad/glad. This is just going to be glad. I have them all just dumped into the windowing folder now, so yeah, doesn't have the same file structure as my C engine. Failed to load OpenGL. That's we're a little bit further, I think. So failed to load OpenGL came from the glad load here. Let's try to do that after we've set up our context. So down here, I think when we load it may matter, or maybe I shouldn't even be calling it. Is 0 even false? Yeah, okay, cool. Hey, look, it's cornflower blue. Nice. So OpenGL is now working inside of the Win32, and that means that we're pretty much good to go at this point because that's all I needed to set up for this issue. This issue is just get OpenGL running, a sign of life, if you will. So now that we've done that with Win32, we're going to have to go over to X11 and set up OpenGL to render to cornflower blue with X11. And we are going to share code here, specifically the GL clear and the clear color and clear. But for now, we're just going to copy and paste that stuff in. Let me get rid of these. Oh, I'm still working on that one, I guess. Hey, cool. Set up context. Should that init be part of the context? I don't know. We'll deal with that later. I think that's fine enough. So we're going to jump over to X11 and try to get this guy working. All right, so I found this on the Chronos page for X11. Sorry for the color change from dark to light here. Stark. We've got GL, GLX, and GLU for what it's using. This is using matrix, load identity, clear. This is using the begin and end. So I want to make sure that I am using the more modern version. Although this is nice, I do need the libgl. So I want to copy that over. Let's see if I can find a more modern version of that. But first, let's go to our build sh here. And oh, that's JavaScript. And let's add GL into that. Let's add it into build sh, add it there, and let's add it into the VS Code launch after X11. Now, we are probably going to split out Vulkan and GL. I don't know. We could do it at runtime to swap the render at runtime. That would be dope. Might be the easiest way to do it. Just bundle them both in. But that could just be a waste of space. So compiling as a specific version, I'm not sure. We'll come up to that when we get to it. But for now, we're just going to pack it all in. And let's go back to our X11 and see what else we need. Okay, I think this one is more along the lines. This is an OpenGL 3.0 context. And so I'll base it off of this one and see what we come up with. We don't need, let's see what, we have X11, we have LGL. Cool. I think those are the only linkers we need then. All right, cool. So let's get started on setting this one up. So it looks like right away, this one, we have the xlib. We're going to also include gl/gl.h and glx. That's where we're going to start with that. And let's find where we do x open display. Okay, cool. So we can select the default screen and everything. In their example, before we even get to that, we're setting up the OpenGL stuff. And this is similar to what we were seeing in the other one where it was a struct to set up all the attributes. So say static and visual attributes. And we don't even need this to be static. It can go away when we're done with it. So we set up the visual attributes, glx, x renderable, true, glx drawable type is going to be, oh yeah, that was the window bit. glx render type, RGBA bit, make sure that's the same. glx visual type, color, or true color, red size, green size, blue size, alpha size, glx alpha size, texture alpha size. I think it's just glx. Oh, that was pulling on the other thing. glx alpha size is 8. glx depth size 24, so that's the same. glx stencil size 8, that's the same. glx, double buffer is true, and then none is the end of the array, so it knows when to. Essentially, this is a trick in C where you can, if you're not used to C, where you can put something at the end, and then you can have an arbitrarily sized array, and you just keep going through it until you find the end marker or the null or whatever. So here they're checking the glx versioning, so and glx major, glx minor, if not glx query version display and glx major and glx minor, or glx major is equal to 1 and glx minor is 3 and less than 1. That's exactly what they're doing. It probably pulled it off of the same page. Yeah, let's do it like that. Okay. So this is going to be, I didn't bring over the fatal messaging code from the Win32 cleanup issue. So I'm actually going to grab this write fatal and put it up in the shared mem. Oh, not Go. Shared, the shared, I think it's in windowing. Yeah, here's where that stuff is. Shared memory blast, and I'm also going to have write fatal there. Cool. So Now we can do the write fatal event shared memory size valid GLX version. And we can write fatal here. Failed to open the display. Okay. Carry on. So after they check the version, they go through and they choose the frame buffer configuration. So int fb count gl x fb, is it frame buffer? Config fbc is equal to glx choose fb config. We're going to pass in the display default screen. We already have default screen here, so let's pull this up here. Okay, so we don't have to call that twice. Default screen, visual attributes, fb count, and now we're going to pick the best one. So int best fbc is equal to -1, worst fbc is equal to -1. This is all should be in a function. Best num swap, worst num swap. And then for int I, actually, why does it have the I outside? Old school coding reasons. Okay, cool. Int I is equal to 0, I is less than our fb count plus I. And I want this to look more like Go code, even though this is how I do plus I in my C code. I do I just so it's closer to looking like Go since we're calling this inside of Go. This may be exactly what they're doing in there. So let me see, visual info, get from config, if vi. I like this to be explicit. And swap samples, glx config, display, get sample buffers, glx samples. These are all so good so far. Best samples, best FBC is I, worst FBC, okay. And setting up those and then doing the free of the VI. So that's all the same. Glad I didn't have to type it. glx fb config, best FBC config. I'm pretty sure that's what the C stands for, but whatever, config. Then we're going to free this. This is probably the best part of AI when you're copying code from the internet. You don't want to just copy and paste. You kind of want to go and see what all it's doing to understand it. That's the reason I type it out rather than copy and paste. The AI can just put it in there. I guess what's the difference between me copy and paste and look at it? I guess because I changed the variable names. That's why I like having a certain formatting. So, it's slightly better than a copy paste. We can say that. So we're going to get from the config, and then let's see, we're going to do the set window attributes. Yep. Then we're going to do a color map. SWA color map. They have a color map. Where are they using this C map? Oh, they're double assigning here. Okay. Well, I prefer to. Why even do that? Probably going to change it later. Hold on, I need to review their code. Okay, no, they just have a variable in there that does nothing, so we can skip that one. Set the display, root window, visual, and then alloc none. We want to say the background pixel map is none, the border pixel 0, the event mask, SWA.event mask equal to structure notify mask. Okay. Also, we have a root window here. Oh, this is VI screen. Okay. Yep. Next, we create the window, and that window is going to have display, root, and instead of S, it's going to be VI screen. So perhaps I can pull that out, It's calling it twice unless this is doing something with it. Going to keep the positions that I put in there. Not sure why I put 1 here. They have 0. I'll put 0 just to match it. And then we're going to put in the, oh, shouldn't be create simple window. This should just be create window. Yeah. Display root 1010. I just don't want it in the top left corner, I guess. We don't need black pixel or white pixel. We need to do VI depth. We need to do input output. We need visual, and then we need CW border pixel. And then let me see, CW color map, event mask, and SWA. Those are all good. I'm just gonna do that to clean it up a little bit. So now we want to make sure that there is a window, which apparently I wasn't doing. We're going to write fatal field to create the window. And we can free the VI now. So we do X free VI. Okay, now we can set up the name. We can do this, the map display or map window. And then after that, they have a GL extension set up. So const char star GL XEXTS is equal to GL X query extensions string. Display S. And now we're going to create some attributes. I'm just going to copy this in. It is not necessary to create or make current to a context before calling this. Okay. We don't need to copy that comment. So here we're getting the proc. I don't know why we set it to 0 and then get the proc. I'd rather just get the proc. Thank you. Clean up this stuff. I don't like all the spaces. Okay, so that gets us that function pointer. Okay, they're setting up a context and checking for an error. We should probably do that. Context CTX is null. They set it to 0, but we're going to set it to null. And then we're going to say CTX error occurred false. Is this a variable they have set globally? Or created globally? They do. It's just a static global. That will mean we can't have a whole bunch of windows. I think we'll come back to this error handling to do deal with CTX errors. Okay. So we're going to check if the extensions are supported, which I think is a function that we have to write. Yeah, they have a helper function for if the, I'm going to leave a bunch of space here so I know where I left off. They have a helper function for checking if the extensions are supported. Static void or bool. And let's see, yeah, we have standard bool in there. Is extension supported? Const char star ext list const char star extension. So const char star start. We're just going to copy theirs. They're pretty much going to go through the list and just do the checking. So where terminator if where is not 0, that's what they do. Now it's going to do a for loop for start. Start is equal to the extension list where the string it's not where break, terminate where string length, where start where -1, terminator, true. Sorry. Okay, so it's just essentially looks like it's just going through a bunch of strings and they're delimited by a terminator character, and then using that as figuring out. It's kind of like splitting on those guys. So now we can go back to our big space that we left and add in if not glexts glxarb create context, or not glx create context attribs arb. This is going to be it's going to say that so this isn't like a break error. We're just going to create the context is equal to create new context, D, the best FBC, type 0 true. Got that right. The else is context attributes 3, 3. Okay, it got the correct one. The example is 3, 0, but we want 3, 3. And then these two are commented out in the example. So I'm going to comment them out. Actually, let's go to the Win32. This is where worlds start to collide. Context flags, A or B. Yeah, we have that one. We also have flags, which is set to the context forward compatible bit, which we have here. Why is this separated? I'm just going to put it on the same line, deal with that later. And then we also have context profile mask A or B and this guy. So let's put a comment here to figure out GLX. I think I just replaced WGL with GLX. Call me crazy. Let's try it. Okay, and then lastly we say the context attributes. Okay, and now also inside of this else we have the xsync false. Is this inside this else? Their tabbing is weird. Yeah. If not CT, this is the context error. To check CTX errors. Then we're gonna, this is a success if there's no context errors. If there is, it reduces the version, which I suppose we can do. Check context errors, and if so, then do the following. And since we're not actually going to be running this code right now, I'm just going to copy and paste from the example. Looks like it's just lowering the version, and best FBC, calling this. So we'll comment this out. Okay, so now we can do an xsync display to false, and this is outside of, oh boy, hold on, let me make sure I got this. Yeah, it's outside of this else statement. Some people need to learn how to tab their code properly. It's just so annoying that they put spaces all over the place, like it's some kind of potpourri or something to make it look more beautiful. But in actuality, it just makes it incredibly hard to read. Okay, I don't think we're doing the error handler, so I'm going to just comment that out. To do check context error again, or just say check context error, as well as CTX. So if CTX is equal to null, here's where we're going to fail the GL context, so that's good. And then we're going to say if, oh my gosh, like whoever does this, GLX is direct. Like look at this, display CTX. Like this is atrocious. Why is there space here? 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 People are just absolutely space happy. And if you do it this way, you're forgiven because you're here checking out this project. But come on. Notice I don't even put spaces in between my code unless, for example, here I have a to-do to break it up. But generally, this is how my code looks. If I have random spaces in here, it's because they're two separate ideas and it should be in a function. And arguably, all of this needs to be in a separate function. It's way too big to be in here. But I digress. We all have our sins, don't we? Anyways, sorry for the tangent. Indirect rendering context obtained. So I don't even need to do this. This is just printing out stuff. So we're going to make the context current. This is where we're at now. Oh my gosh. Okay, and when, did I call mine when? Display, where did I create the window? I called it W. W. Okay. Arguably, that was a bad name. Now that this thing is growing. Okay, so now we can deal with our buffer swapping stuff. So let's go down to, let's go copy our cornflower blue. Cornflower blue. We can even give that a name. It's probably going to go to black eventually. It's not going to be cornflower blue, but it's fun to start. So we have expose. I think this is where we want our code. Not sure yet. I am not a X11 master. DW. Okay. So here we want to also clean up the context at the end. So before we destroy the window, we're going to do glx make current display 0, 0. I bet you one of those needs to be null and not 0, but whatever. Display and context. Then we destroy the window. We need to free the color map. Is that why they're setting the color? What do we need to set the color map to free it later? Is that what's going on here? So we're going to go back up to where we did CMap. Apparently, we may free it. Color map. Oh, here it is. So CMap. So we're going to do color map, CMap, and we're going to do a double assignment just so we can free it later. I'm assuming that's the reason. I don't really like double assignments. There's a lot of stuff I don't like, isn't there? Code the way you want. Everybody codes differently. Okay, cool. So we can see how this works. I can run X11 on my primary computer here now. So let's build it. We're going to go to our build sh. We're going to copy this export flag, paste it in there. I gotta actually be in a subsystem. Okay, so we're gonna export that, and we're gonna call our go build and see if we get any errors. Yep, GL. GL. Is this because it's supposed to be a capital GL? Yeah, it is. So let's GL. Okay. Let's try to build again, see if that makes it happy. No, it doesn't like GL. I may not even have GL in this subsystem. Let me see. ls/user/include GL. Oh, I do have GL. Hold on, let me find the correct one real quick. Okay, I just needed to download it into the subsystem. So let's go back to build. Okay, now we're gonna get display. This is just bad. No, not delete, just D. Let's see, that was the only one with display. GLEXTS. I think this is capital E. GL X context attributes ARB. Okay, let me just get rid of the clutter and try again. Unknown type, GLX create this proc. Okay, let's find out why. Okay, perhaps it's not needing to be a, hold on. No, it's suggesting this because I have it here. Maybe proc is all caps. Let me see what it is in the Chronos sample. Oh, they type define it at the top. So let's go to the top and let's paste that in. So we type define it the same. Oops, didn't mean to press F5. Okay, it's clear. Let's build again. Now we are getting GLX EXTS, GLEX. So we should probably paste that in, make sure it's the same. The next thing is expected this before at none, G122. None. We need a comma here. I can technically put a comma there, but whatever. Be more Go-like if we did. So the string copy S, this is not something that we have inside of Linux. So we want to, let's just change that. Where was it? Windowing H. String copy S. We can just do strcpy. We're going to do mem start. Then we're going to do the source, but see how the source is could be too long. So we actually don't even need to do that. We'll just do a mem copy shared memory, the message, and instead of doing the string length here, because the string length could be too long, we want to say int msglen is equal to the string length, and then if the size is greater than the size minus the start, it becomes this. And we want to do -1 because we need to null terminate our string properly. So we will do the message length, and then we can do message length, event shared message length plus the start, just for clarity. We'll put the start and then the message length, and then that'll be equal to 0. So that will be our write fatal, and that should be cross-platform. The underscore S functions are a bunch of Windows nonsense, and I use them by habit at times. So string length is implicit because we need to include string.h because we copied it over here. I pressed F5 again. Okay. Now let's build. Come on, be happy. Include include Windows. Why is it including Windows? Glad underscore. Let's just copy this. It's in the glad code. When if not defined, what if not defined when API do this? What? Glad WGL. Am I even including glad? Oh, glad C. Okay. So I probably just want to block out this glad C from compiling if we're on anything other than Windows. If defined Win32 or defined Win64, then I'll just close that off down here. And we need to do the same thing on the other C file here. We're not even using these guys right now. I don't even think we do use them in X11. See if that makes it happy. Okay, so that compiled. Now to see if it ran, or if it runs. No, it doesn't. We have some failed to load driver stuff. So we have a glx bad config. So let's check out what these are. It could just be because I'm running it in WSL, OpenGL instead of OpenGL kind of scenario. Glad, Win32, glad, window X11 launch. Okay. So let's take a look at, choose the config. I don't even know where it's dying at. So I'm going to print out and figure out where exactly we're dying. Okay, I was trying to run it on Windows through WSL, but I was wrestling too much with the WSL GPU stuff, so I decided just to come over to my Linux laptop, and first time run with the changes seemed to all be working. I can close the window and it stops debugging, and my battery's low. Cool. So that's a fully functional OpenGL on both Windows and Linux.